Now we're going to turn to molecular compounds. Molecular compounds contain two or more nonmetals. The ones we're going to learn in this class have exactly two nonmetal elements. Okay? The good news for you is students tend to like naming these more because they're easier than the ionic compounds. So two or more nonmetals, and we're just learning the two-element or the binary molecular compounds. There are no charges here because the nonmetals, when they form ions, they both would form negative ions and there'd be no attraction there. So there's no ions. So the ions is what helped us to figure out how many of each ion there were, and since there's no charges, then we need some other assistance in figuring out how many atoms of each element. So we use numerical prefixes. The element, the first element, we just write its name, and here's the prefix, is going to tell us how many. The second element changes its name as if it were getting married, changes the ending of its name like it would be if it was an ion, and then it also has a prefix that tells us how many. These are the prefixes. Most of them should be familiar to you. Mono is the prefix for 1, di for 2, tri for 3, like a triangle has 3 sides. Tetra might be strange to you. Tetra means 4. Anybody familiar with the game Tetris? All of those shapes that fall in Tetris are made up of 4 squares. It's not a coincidence. It's named Tetris because of that. Penta, pentagon has 5 sides. Hexa means 6. Hepta's kind of weird. Might not remember that one. Hepta is 7. Octa is 8. That one's pretty good. Nona is a lot like the word 9. And deca is 10. A decade is 10 years. So you need to know these prefixes, but that should be fairly simple. So we put the prefixes in to tell us how many of each of these nonmetals we have. So if we look at CO2, 2 nonmetals. We've got carbon and we've got oxygen. So carbon is just its element name. The oxygen becomes oxide. And there's only one of these. So the prefix for 1 is monocarbon. And there's 2 oxygens. The prefix for 2 is di. So dioxide means 2 oxygens. So here's another situation where chemists avoid the number 1. And it's really just to make things simpler. If the first element has only 1, we drop the mono. So instead of saying monocarbon dioxide, we just say carbon dioxide. And there's a little bit of ambivalence about, sometimes you might notice that the mono is dropped on the second one as well, but we're going to go with always writing mono on the second one, just to be consistent. All of those prefixes end with vowels, and sometimes the base name starts with a vowel, and so then things get kind of wonky. So N2O, which has the common name laughing gas, there's 2 nitrogens, so that would be dinitrogen, and there's 1 oxygen, so that would be monooxide. But the 2 O's in a row there look weird. Yeah, I'm writing with an eraser. That looks weird too. Monooxide. Monoxide? What is that? So we drop this O. I'm telling you this because I want you to be aware of it. I will not try to trick you with this on an exam. In the homework or anything, don't worry about it. But sometimes you'll see that ending vowel of the prefix is missing, and this is why. Okay, so dinitrogen monoxide. So let's name this compound. We recognize this as a molecular compound because it's 2 nonmetals. Students tend to like this prefix business, and so then they want to use it everywhere. You can't use it for the ionic compounds. 2 nonmetals. So what would the name be? Dinitrogen tetroxide. So dinitrogen, meaning two nitrogens. Tetraoxide, you'll also sometimes see tetroxide. Honestly, I'm not sure which is the most correct, and I don't care. So either one's fine with me, tetraoxide or tetroxide. Any questions? Name this one. So the systematic name would be nitrogen trihydride. But what do we actually call that? Ammonia. I might try to trick you with that one. And I'll definitely try to trick you with this one. What's that? Water. Could we name it systematically? Yeah, what would it be? Dihydrogen monoxide. So you can go home and freak out the people you live with and say, in chemistry lab today, we drank dihydrogen monoxide. We're all going to die. You drank water. So I don't do a lot of examples about that one because students tend to get that very quickly.